a look at this one. We want to find f. So that means find the original. If f prime is this loveliness and f of 0 equals -2. So my derivative, actually I'm going to skip this one if you don't mind, because this uses an inverse trig function and I didn't make you memorize those. So I'm going to skip that one. Sorry. Let's go to this one instead. Okay, find the original function if the second derivative is equal to that. So if we work backwards, you're at the second derivative, one step back would take you to the first derivative. Okay, so yesterday, how did I tell you to do the derivatives? You add 1 to the exponent, then you have to multiply by the reciprocal. Do I need to write like 12 times 1/3, or can I go ahead and just put 4? Is that okay? Okay, so this, if I add 1, it would take me to a square, so I have to multiply by a half. 6 times 1/2 is 3. Minus the antiderivative of 4 would be 4x. Okay, nice thing about this, we can always check with doing our derivatives. If you bring that 3 down, you get 12x squared. Bring that 2 down, you get 6x. Bring that derivative of x is 1, so that would give us a -4. The other thing we need is plus c, because we know the derivative of any constant is 0. So when we're doing antiderivative, we have that constant. So now let's go to the original function. What would be the antiderivative of 4x to the third? You would have to take it times 1/4. 1/4 times 4, which would just be x to the 4. Do I need to write out that step with the 1/4 times 4? You guys sure you know where I'm getting it? Antiderivative of 3x squared. So if you add 1 to your exponent, that's x cubed. So you multiply it by the 1/3, and it would cancel. Minus, if you add 1, that's x squared. So 4 times a half is 2. What is your constant going to get with it? It's an x. Just like -4 was a constant, when we did the antiderivative, it got an x added to it. C is just some number, so when you do the antiderivative, you get an x with it. And then what would we need on the end? Plus another constant. Let's do a letter other than C, because those don't have to be the same, so let's say K. All right, I want to know what C and K are. So now we use this other information. F of 0 equals 4. That means in the original function, if x is 0, the whole thing equals 4. If you put zeros in for all of your x's, we get 0 plus 0 minus 0 plus 0 plus k, and that is 4. So we know that our k value is 4 now. All right, but we need c, so that's where we use this. F of 1 equals 1. If I put in a 1, 1 to the 4th is 1. 1 cubed is 1. Minus 2 times 1 squared is 2. C times 1 is c, and we already said k was 4, and that has to equal 1. So put c plus 4 equals 1. So c is -3. So the original function had to be x to the 4th plus x cubed minus 2x squared minus 3x plus 4. So when I give you those points, I'm giving you the information to find the constant value. Any questions on that one? Sometimes these are called initial value problems. Essentially, it's the same thing. You're doing the antiderivative, but I'm giving you the information to find your constant at the end. So, if I know f prime is equal to this, it might be beneficial to you to rewrite 3 over x to the third. How could you write that? So the antiderivative of x to the fourth would be all right. Antiderivative of negative 3x would be 3 halves x squared. All right, antiderivative of 3x to the negative 3. So if you add 1 to that power, it becomes x to the negative 2. So you have to multiply by negative 1 half. So it would be negative 3 halves x to the negative 2 plus c. Right. But now I have given you the information you need to find c. I told you that f of 1 is equal to negative 1. So if we go to this and we plug in a 1 for all of our x's, we get 1/5 minus 3 halves minus 3 halves plus c, and this has to equal negative 1. All right, so this would be 1/5 minus 3. So we get Are you guys just waiting for me to do the math? Come on.
Why was that? 14 bits.
You're a step ahead of me. And then if you add your 14/5 over, be like negative 5 over 5 plus 14 over 5 would be 9 over 5. So our final function, 1/5 x to the 5th minus 3 halves x squared minus 3 halves x to the negative 2 plus 9/5.
Totally did that.
Well, you should. Yes.
On this term right here, did it become negative because that had to be a negative 1/2 because that's a negative?
Yes.
Okay, I missed it.
Other questions there? All right. This one's a little bit different. This is the graph of a function. I'm going to graph the antiderivative, given that f of 0 equals 2. Okay, so essentially, this is like the derivative. Okay, you know if the derivative is negative, what does that tell you about your original function? Decreasing. When the derivative is positive, your original was increasing. F of 0 equals 2 is just giving us a point on the graph. When my x is 0, my y is 2, so that's a starting point. So we know our graph's, the derivative was negative, so we have to be decreasing. Did I give you any information to tell you like where it stopped, or the y values? But we know that right here is when the derivative is 0, so that's when we had our minimum. And then the derivative was positive, so we have to be increasing until we get to 3, so whatever that might look at. But then at 3 we switch to decreasing again, so coming down. And as this is flattening out, that's saying the graph is still decreasing, but barely. It's getting smaller and smaller, so it's kind of like acting like a horizontal axis. something like this. Is it perfect? No, because we don't have ordered pairs or anything, but we have the general shape of that. All right. So, let's remind ourselves about motion. Position, velocity, and acceleration. How are those related?
Position is your function, velocity is your first derivative, acceleration is your second.
All right, so I have a lot of examples involving this. We are probably not going to do all of them, so we'll kind of jump around a little bit and see which ones, how much we need. So if I asked you to find the particle's position function, x of t, when a of t is 10 minus 30t, x of 0 equals 5, and b of 0 equals negative 5. I'm going to give you guys a minute. I want you to try this. See how far you, how do we get velocity? Acceleration is the second derivative. So if we work backwards, the antiderivative of this would be velocity. What's the antiderivative of 10? Except t is our variable here. Minus the antiderivative of 30t. And then we would need plus c. Okay, did I give you the information to find c? Because I told you the velocity at time 0 is negative 5. So if we put in a 0 for all of our t's, we just get c equals negative 5. So the velocity function is 10t minus 15t squared minus 5. So now if I go backwards from velocity, we get the original, the position function, because we're doing the antiderivative. Okay, so remember, acceleration is where we started, so when we did the antiderivative, we had velocity. If we do the antiderivative of velocity, we'll get position. So what's the antiderivative of 10t? Antiderivative of 15t cubed, or t squared? Antiderivative of 5. And then we have a constant. I call it k just because I already used c once, but it doesn't really matter. We know that the beginning position was 5. So if you plug in 0 for all of your t's, your k is 5. So our original position function, 5t squared minus 5t cubed minus 5t plus 5. Okay, so it's just a matter of doing the antiderivatives again. You just have to be able to apply it. Any questions there? I'll have to try at least one or two more. A particle starts from rest at the point x equals 10 and moves along the x-axis with an acceleration of a of t equals 12t. Find the position function. Okay, so I know my acceleration. If you have acceleration, what can we get from there? Velocity. So the velocity would be what? 6t squared plus c. Okay, here's what we know. If it starts from rest, so that means the velocity at the beginning was 0 because it was at rest. So if you plug in 0 for your t, c is 0. So our actual velocity function is just 6t squared. All right, but I want position, so how do we get position? So the antiderivative of 6t squared plus a constant. Okay, here's the other thing we know. When it starts, so our position at time 0 was 10. So our position function is 2t cubed plus 10. I did. I put in a 0 because it was the beginning position, so times 0. Let's do one last problem and then I'm going to have you guys practice on your own. A particle moves in a straight line and has acceleration 6t plus 4. The initial velocity is -6, the initial displacement is 9. Find the position. This time I called my position function s. Sometimes it's called s, sometimes it's called x, so just be comfortable with either. So what do I do first? Okay, so antiderivative of acceleration is velocity. So that would be 3 plus 4t plus a constant. But if at time when x is 0, we get, or when t is 0, we get -6, what's our constant? Okay, then from here, if I want position, antiderivative would be plus minus plus a constant. But I know if I put in 0 for all my t's, we get 9. So that tells me my constant is 9. Any questions with these motion problems? So I want you to add to yesterday's. I'm going to take off problem 69. So you did 1 through 17 yesterday, so we've got